Hey folks, so this video is going to be about file I/O and EZ68K. EZ68 actually comes with a pretty good file I/O source. You just go to wherever you installed EZ68K. It's in the examples folder. It's just called file I/O. It covers a lot of things that I won't be touching on, like writing to a file and stuff. I'm only going to be talking about reading a file. So if you want to know about writing and fancy things, check out the source that comes with EZ68K. So we're going to open up my source here. It's just a blank source. I saved it to my desktop here along with this file.txt, which is just a text file with 1, 2, 3, 4, 5 in it. We're going to be reading that file into memory. Now first thing we want to do is we want to make a file name variable. So we'll do dc.b, that's declaring a constant in a series of bytes, and our file is called file.txt, and the comma is 0 means that's null terminated. That's our kind of like end of file type thing. It indicates the end of the string. And now we want to use LEA. LEA is like move, but for addresses. So we want to move the address where file name is into A1, and I'll explain that in a second. I'm actually going to set this to start at 2000 as well. It's just a little easier, and you'll see why in a second too. I don't want 20,000, my bad. 2,000, okay. So we're just going to run this real quick and see if that worked. Okay, so A1 contains 2,000, that's great. So now we're going to go to View, we're going to go to Memory, and we're going to scroll down to 2,000 in this column on the left here. I'm going to scroll down to 2,000. Remember, our addresses are in hex, so you're going to see some weird numbers there. And bingo, file.txt is in 2000. That's what we want. That's good. So we can close that. And now I want to show you who your new best friend is going to be. It's the help menu. So you go to the index tab. I think it opens contents by default. So you go to index, you type in file. It should be the very first thing that comes up. It's the file IO help file. This shows you all of the trap tasks. So we want trap task number 51. Number 52 does the same thing, except that if the file isn't found, it gets created, which I don't really like. Really just because we want to use the file.txt that we have already. So we want to use trap task number 51. So that means we got to move number 51 into D0 and then trap 15. So what will that do for us? That will give us the post condition of D1 containing the file ID, which we do need, and I'll show you in a second. It's for number 53 here. If we look at the precondition, we had to have our file name in A1, which we already did with LEA at the start there. So now that we have our file ID, we can move on to number 53. So the precondition is that our file ID is in D1. Yeah, we did that. A1 has to be the buffer address. Okay, so now we have to create the buffer. The buffer is essentially where your file will be, which address the actual file contents will be in. So we're going to declare space, ds, declare space. We're going to make it some byte size, and we're going to do 80. That's a pretty safe number. And we're going to do the same thing. We're going to move the address of buffer into A1, and now we're ready to do what was that? I think it was 53. I'm going to do 53. Yeah, I'm going to move that to the side. I got two monitors, so I'll be able to see both things at once. Okay, number 53. Move that to D0. We'll do trap 15. Okay, and oh, there's another precondition here that we got to do. D2 has to hold the number of bytes to read. Okay, so let's do another thing down here. Let's call this file size. This will be a constant, so declare constant. We're going to do bytes again. And let's read 80 bytes from our file. We only got 5 bytes in there, but 80 bytes should be fine. It's a good save number. So d2.l has to contain our number of bytes. Okay, so My video just skipped a little bit there, but I just typed this line in, so we're going to test it and see if it works. Okay, good. However, I did do a mistake. This should be up here because it's a precondition. Right, so if we look at our help file again, if we look at number 53, so pre-file ID has to be in D1, yeah, we did that. A1 has to be the buffer address, yeah. D2 has to contain the number of bytes, yeah. And then D2 will hold the number of bytes actually read. That's good, that's what we want. Okay. So now buffer should contain our file. The moment of truth, let's see if that worked. Cross your fingers. Okay, so buffer is going to be at 2000 something. So let's check out our memory. And yeah, there it is. So 31, 32, 33, 34, 35. That's our file. Just to prove it, we're going to change the contents of file.txt to 94537. Okay, remember that obscure number. Execute again. I think half the time taken by this video is just executing. Window takes time to pop up. Alright, so do you remember our obscure number? 39, 34, 35, 33, 37. Yep, that's good. So the reason why it's in the 30s is because it actually converts ASCII. It does not convert the actual numbers. So if you wanted to get the real numbers, you'd have to go through the address stored at A1 and subtract 30 from each one. So I'm going to cut out for a second and cut back in with a loop so we can see how that works. Alright, so this is our loop. I'm just going to go through it real quick. The reason why I cut out is because I didn't want to focus too long on just the loop. It's kind of a basic concept. So this is your counter. We're moving our counter to D3. We're going to subtract 1 from it each time, so we only go through for 5 items in our file. So that's what tst.b does. It checks if our counter is 0. If it is, if it's equal to 0, we branch to done, which is just the end of the program. We subtract a hex value of 30 from whatever's in A1, and then we subtract 1 from our counter, and then we just branch back up to loop. So if we remember, I closed it, but if we remember our obscure file, 94537, then we execute here. Okay, so let's execute. It was successful, good. View, memory. So now our contents of our address register are the numbers we wanted. Yeah, so I hope that helped out. It is kind of a hack that you have to subtract 30, but I talked to the guy who actually made Easy68K, and that was his suggestion, was to just subtract 30. There isn't really a surefire way of converting ASCII to just a number to work with. So anyway, yeah, I hope that helped out. Feel free to subscribe and suggest ideas for new videos. And thanks for watching.